This is your teacher Nada Saab. This presentation is about the periodic table. You can find a PDF copy of this on my site. Okay, the first slide is about the subatomic particles. I'm gonna be emphasizing basically on two of them. I'm gonna be emphasizing on the electrons and protons. Electrons are on the energy levels and protons are usually in the nucleus. You need to know also that the protons and the electrons have the same charge but opposite signs. The electrons are negatively charged, the protons are positively charged, and again the protons are in the nucleus, the electrons are around on energy levels. We've seen this atom. This is like a simple structure of the atom, as I said before, and then you see like the first energy level can hold maximum of 2, the second 8, the third 18, and the fourth 32. And this is the nucleus and the center that has usually the protons. Okay, this table here, I want you to remember what's in here exactly. So you read it, you try to remember it, and you need to know that basically the atomic number is the number of electrons is the same as the number of protons, and the period number is the number of energy levels. And then the valence electron are usually the electrons on the last energy level, and they're usually the group number. And you need also to know that the more protons we have in the nucleus, the stronger is the nucleus. Okay, so this table you have to read and think about it. I have an example for you here. I have a potassium. Potassium has atomic number of 19, so it has 19 electrons, 19 protons. Usually the number of electrons is the same as the number of protons. This is the electronic configuration. It ends with 4s1, so it has 4 energy level. The last energy level is level 4, so it's in period 4. It has 1 electron on the last energy level, so it's in group 1 because it has 1 valence electron. So potassium is in group 1. It's in group 1, it's in period 4. Okay, and I have it for you here. You can see it. This is a potassium. It has 19 proton in the nucleus in here. It has 2 electrons, 2, 8, 10, and 8, 18, and 1, 19. The last energy level is energy level 4, so it's in period 4. The number of electrons on the last energy level is 1, so it has 1 valence electron. It is in group 1. Okay. This is a chlorine. I want to read this and see how the same thing I did for chlorine. This is neon, the same thing for neon. And I have more practice on those on the table that you see here. So you need to read everything in here and what's on this in each of the columns. And then the representation of the atom and the size of the atom. Okay, so the periodic table is usually arranged according to the atomic number. Is, as I said, in the periodic table, as you move, it has columns and rows. The element in the same column, they have the same number of valence electrons, so they are element of the same group. The horizontal row is called the period, which means that these elements have the same number of occupied energy levels, because usually by definition a period is the number of occupied energy level and a group is the number of valence electrons. This is it here, like group periodic table. This is a group 1 2 3 4 5 6 7 and then 8, and then if you move across that will be period 2, period 3. So for example, if I take lithium, okay, so if I take lithium, for example, let's take lithium here. Lithium will be in group 1 in period 2. This is how you read it. Okay, and this is another representation of the periodic table based on the electron configuration. So you have in groups 1A, in group 1A, in group 2A have their s orbital filled, and these have their their p orbital filled, and the element here have their d orbital filled according to the electronic configuration. Okay, I want you to notice here the size, how the size of the atom change as you move down a group like this, or as you move across a period. And you notice that if you move down a group, this size increases, and as you move across a period, this size decreases. Okay. Why is that? Because as you move down the same group, what happened? As you move down the same group, the period number increases, which means that you're adding more energy levels that makes the atom bigger. So adding more energy levels makes the atom bigger. That's easy to remember. And you have here some explanation. So you notice here that I'm moving, you notice here that when we move, you have lithium, sodium, potassium, those are all in group 1, but we're moving down, and then as we move down the period number increases. So lithium has 2 energy level, sodium has 3 energy level, and potassium has 4 energy level. So increasing the number of energy level makes the atom bigger. That's why potassium is the biggest here. Okay. As you move across the same period, what happened? When you move across the same period, the number of energy levels stay the same, but the atomic number increases. That means the number of protons in the nucleus increases. When the number of protons in the nucleus increases, the nucleus becomes stronger, and it will pulse the energy level to it more, which decreases the size of the atom. Okay, let's see here. For example, in here, let's look at where's this first. Okay, let's look. Okay, I have here lithium, beryllium, boron. They're all in period 2, so they all have 2 energy levels. So each one has 2 energy levels, and you can see them here: 2 energy level, 2 energy level, 2 energy levels. Now the boron has more protons than beryllium, than lithium. That means the nucleus for boron is stronger. That means it will pull the two energy level closer to it. That's why boron is smaller than beryllium, and then beryllium is also smaller than lithium. Okay, so this is just brief explanation. I expected to read all of it. I put a lot of time into making this stuff, so I appreciate if you read it. If you have any questions, email me and then let me know. Good luck.